Welcome back, friends. In this video, we'll look at yet another enhancement of the Tux of Math game, in which we'll get two-digit numbers to be part of our questions, right? So before I get on with that, let me just show you what I mean. Remember, in the original game, we had, let's say, 5 plus 3, 6 plus 9, always a single-digit number coming in. But we'll enhance this game that we sometimes end up with a double-digit number. So, for example, 79 plus 8, 75 plus 4, 88 plus 5, and so on and so forth. Of course, this number can sometimes single digit also, but we also have a provision to make it double digit. Now, what I'm going to show you is how do you do this on the left number, but you can imagine that you can do it similar logic on the right side. In fact, you can extend this to any number of digits if the logic is clear in your head. Yeah. So bunch of things we are going to do, but let's just see the idea first before we get onto the code, right? So the first thing, as you can imagine, in the original game, these are all clones and we are using lists to keep track of where these are going. We are going to just extend this approach, and instead of creating 3 clones per question, I'm going to create 4 clones, right? The fourth clone will be the extreme left clone, which will be the tens digit, right? So for example, in this case, 7, 7 or 8, right? But so that part is similar. So basically all the lists, along with all the lists, I'll also get this extreme left clone ID list, and I'm going to do the same treatment that I was doing to all these lists to this list as well, right? So everything, structurally, everything is intact here, right? However, there are 2 questions that come up. Number one is that what is the number that is formed when the left clone ID comes into picture, right? Remember, here for us it's very simple, right? We see 79, we see 7 and 9, we know it's 79, but then the scratch or the sprite has to be told that this is the number that we are talking about, right? So that's number one thing. Number two, we have to also figure out which costume should I assign for the extreme left clone, right? So here in my example, I have all these 3 as 2 digits, but I want to keep it flexible. I want to say, okay, sometimes maybe I'll get 8 plus 5, right? Now it looks really odd to say 0, 8 plus 5. So which means that I have to keep an empty costume. And if it's a 0 here on the tens digit, I'll just not display it. So it look like 8 plus 5, just like here, right? So a few things that we have to do. And then we'll also have to change the ending conditions, but that we'll talk about a little bit later, right? So like I said, for the extreme left clone, I'll create an empty costume and we'll assign it to get the single digit numbers. Now, before I move on to the code, I just want to spend some time on highlighting what number is formed. So we spoke about this 7, 9, 79 is really 7 times 10 plus 9, right? I mean, this is basically tens digit, units digit. We have seen this in mathematics so many times, right? So, this part is clear, but then because of the way we have coded this, remember the number is in fact, 1 more than the 1 less than the costume, right? So the costume is 1, then the number is actually 0. We spoke about this in the original project. So which means that when I, let's say, use a variable temp0 to create this costume, the leftmost costume, the number that I'm looking at, the place value of that number that I'm looking at is 10 times temp0 minus 1 and plus temp1 minus 1. I mean, this is similar to the minus 2 that we had, but that's the whole idea, right? That costume is 1 more than the number. And by the same token, if this is the number left, then the correct answer is number left plus temp2 minus 1, because notice temp2 will be in this case 8, 4 and so on and so forth. The costume is 1 more, so costume is 9, 5 and 6 and so on, right? So this part I hope is clear. Spend some time to understand this because this is important, right? Otherwise the answer will be all wrong. Yeah. Now with this done, let's get on with making the changes. So like I said, we are going to create additional clones with a new costume and so on. So I've got this original game here. The only change I have made is that I have already created an extra costume, which is that along with the plus, I have created this empty costume, which is really empty. You can see that there's nothing in this costume, right? Because I want to use this in the situation where my tens digit ends up being a 0. Right now, with this done, I'm going to just go through the exercise and create these clones the way we were doing. But as you can imagine, I'm going to now require another variable called, say, temp0. Now I'll assign this variable. I create this variable and I will assign this just like here, temp1, temp2. I'll assign this to temp0. I'll assign temp0 to pick random 1 to 10. Right now, like I said, the first thing I must do is that once I get this number in place, I must update the right answer. It's no longer temp1 plus temp2 minus 1 because the number has changed here, right? So for that purpose, I'm going to create I'm going to create a variable here. Let's say call it number left, just like I had shown you in the slides earlier. So how do I assign this number left? Now you have to do it a little bit slowly, a little bit carefully, because these operators otherwise can get quite messy, right? So it's something plus something. So what is it? Basically 10 times temp0 minus 1 plus temp1 minus 1, right? So 10 times temp0 minus 1. So let's do this. So I'm going to put this together slowly because this otherwise gives a lot of problem, right? So here, so it's basically 10 times temp 0 is the costume for the tens digit, so it's temp 0 minus 1. 10 times temp 0 minus 1. Now this plus temp 1 minus 1, right? So this is now the place value of the tens digit. Now we have to get temp 1 minus 1. Now I recommend you do this slowly because otherwise mistakes are very easy to make in this, right? So it's basically temp 1, temp 1 minus 1, and I must add these two. So again, I go to the operators and I say 10 times temp 0 minus 1. So this whole thing here, and then I have to be a little bit careful in this. Temp 1 minus 1. And we'll test this whole logic to see if it's all, we've got it all correct. And what should I set it to? So I don't need this plus anymore. I will move this out and I'll take this entire thing and place it here, right? So this is obviously not my clone ID. This should be my number on the left side, right? So the logic is similar. Basically 10 times tens digit plus unit digit, but because of costumes you have this extra minus 1 coming in. Be careful to get these numbers and the brackets correct in this, otherwise the whole thing goes off, right? Now what is the right answer? As we just spoke about, this is actually no longer temp 1 plus temp 2 minus 1. In fact, it is number left plus temp 2 minus 1, right? So and the reason I've seen, because again we're just adding the two numbers. The right number, this is so painful. So okay, I have to do it a little bit carefully here, otherwise it's a painful thing. So I'll say number left plus temp 2. Now remember, this has to be minus 1. Now the best way to do all this is do it slowly and just test your code, right? Which we'll do, and we'll understand what's going on, right? Now with all this done, I'm going to now create the extreme left clone, and for that purpose I'm going to set its costume. However, its costume, unlike all these other things, is no longer just set by temp 0. We are going to decide if temp 0 is 0. I mean, if temp 0 is 1, which means the number is actually 0, we are going to set it to an empty costume, right? So I'm going to put a little bit of code here. So I'll say if and else statement here, and the condition I'm putting is that if temp 0 is equal to, so let me just put it outside here first and then we can integrate with the main code, right? So I say temp 0, if temp 0 is equal to 1, which means the number chosen is 0. So let me be a little bit careful here and move all of this away to this side here, and then I can join all this back here, right? So basically I'm just going to create clones. If temp 0 is 0, then I'm going to say switch costume to in the looks I'll go and say switch costume to empty, because empty costume is what I want if the number is actually 0, or switch costume to temp 0, right? So this part is exactly same as what we had done earlier. So we go to say switch costume to, I have to go use a variable here, say temp 0. Right now this will ensure that my units digit, my tens digit is nicely formed. Now once this is done, this is not sufficient. We are going to have to create clone IDs, right? And create clones. So I'll just use the same logic as I was doing earlier. Instead of doing just a left clone directly, instead I will add basically a extreme left clone, right? So I'm going to, so this is fine. Now I'm going to say okay, so I'm going to say change clone ID by 1, because that will become my first clone, right? So I've done the switching costume, and I'm going to create a clone right away. Right now, one of the things you might want to do, if this clones is too many, you can actually put this in a repeat loop, repeat 3 or 4 times. That may be actually a neater version of this code, right? But for now, we just continue with this. So I'll say create clone of myself. So change clone ID by 1. Now remember, this is the extreme left clone being created, right? So if I want to come to the next clone, which is the normal units clone, I must change x by 25, right? And let's just hang on for a moment. We'll see this in action and things will become very clear as to what's going on, right? So I'll say change, so say change x by say 25, right? So this is just creating the extreme left clone. But remember, in the past we had these lists to keep track of these clones. So I'm going to create one more list here, right? And this just like you have left clone, right clone, I'm just going to make a list called extreme left clone. Right now, what this does is that this list is going to keep track of all the IDs that are used for the extreme left clone. But like any other list, I'm going to first thing delete all of these extreme left clones. So delete all of say extreme left clone. Now with this done, I'm going to have to add the clone ID just like I was doing here. I was going to add the clone ID before it changes to this list called add, let's say here, add, let's say, actually, in fact, I should do it before I do this, so it's a bit more logical. So I'll add, uh, you know, um, add clone ID. So the variables, I'll go and say add clone ID to extreme left clone. Right now, this is quite interesting. Whatever we have done, let's just see it working first. And for this purpose, I'm going to display both my extreme left clone ID as well as the left clone ID, right? And it's just interesting to see what really has happened in this process, right? So we have, the numbers getting from, what happened there? Okay, so extreme left clone ID is 1, and notice now my left clone ID is multiples of 4, right? So because there are 4 clones getting created, right? And I just hope we get one of those, where we have only a single digit coming out. Okay, so I still get 1 digit, 2 digit, 2 digit. Let's see if I just play for a little longer. 83 plus 5, 81 plus 0, 28 plus 0, 64 plus 2. Okay, now you see you got 6 plus 8. That's because the extreme left number must have been 0, right? Now this is fine. So we have created the clone IDs like we were doing. Let's also check the answers, right? So that we are sure that we've got it all correct. So if I look at the answers, let's see it carefully. The first question is 51 plus 5, answer is 56, 75 plus 8, 83, 74 plus 3, 77. So in fact, 84 plus 0, 84, and so on and so forth, right? So this is actually in good shape right now, right? So it's all shaping up nicely. My first step is actually complete. It's quite a long step, but it's complete, right? Now, in fact, we've done more than that, right? So we must figure out what number is being talked about and update the answers accordingly. So we've done these 2 steps. Now comes to the point where I answer the question correctly. Now this part doesn't change. All I really have to do is to just make sure that along with all of this, left clone, right clone, operator clone, I add a similar statement to, let's say, delete list for the extreme left clone as well, right? So I'll say add item index of the delete clone list. Of the extreme left clone also to the delete list. So I must delete this clone as well. Also, I will go and delete this particular index of so I'll just do this slowly from here. So I'll say delete, say index, so I'll duplicate this index. Delete index of the extreme left clone. So notice this part we have done. What we have done is really whatever we are doing for every block that is in there, right? So really what's going on is that if I answer this question now, you should see those things getting disappeared, right? So if I say 24, indeed it disappears. 29, 45, and your game is actually in a good shape right now, right? So notice how we've just used the structure that we had created earlier and we just added a little bit to that, right? But now comes an important step and a little bit, something to be done a little bit carefully, which is the ending logic, right? So yes, our clones are getting deleted, but the ending logic must change because there are 2 reasons, right? First change we must do is that now, unlike earlier, we have 4 clones falling. So previously we had 3 clones falling together, but now because of the additional clone, we have in fact 4 clones falling together, right? So we must deduct life after 4 clones have fallen. Number 2, that remember we are using touching color, right? Now touching color is a problem here because sometimes we may end up with an empty costume, right? And if there's an empty costume, then the touching condition never happens, right? So to do this, we have to change this logic as well, right? So what I'll do is that I'll go back to my game here. I'll go back to this. Okay, this game here. Now I will go to the point where I decide how many clones, so here, yeah. Okay, so I will wait, instead of 3 clones having fallen, I will wait until say 4 clones have fallen to deduct 1 life, right? So that's one change I'll do, because remember these are all falling now in groups of 4, right? It's no longer groups of 3. So I'll say wait for 4 clones before I deduct life. More importantly, or say equally importantly, I must clean up this whole thing, and I must make sure that the condition here is updated, right? So instead of touching color, I will just say change, for example, y position, or sorry, I'll put a condition, an operator here, if y position is less than some number, right? So in this case I can put, say, maybe if say y position is less than, perhaps let's say minus maybe 90 or something like that, because that's where this thing approximately is, and that should be fine, right? So red line has lost its meaning, but this we need to do because remember sometimes we end up with an empty costume, right? So now if you see this game, I've got 50 plus 4 is 54. I'd say 54. Okay, that's nice. 67, 70, it's okay, but let's try not to answer the question, see what happens. These 4 fall. and I lose one life, right? So I lose one life, they're gone slightly below this, three lives, and the game gets over, right? So I hope this was clear to you. Go step by step, go slow. This is not that hard, but it's requires systematic thinking. Okay, take care. Thank you so much. Enjoy programming, enjoy Scratch as always.